brackets. This is MJ with MBGR knowledge. We're looking at Mathematics Paper 1, 2024 internal. And question 1 reads, simplify, that is 3x, open brackets, 2x minus 4, close brackets minus 2, open bracket x minus 1. First of all, it's important to identify your question. So this comes under simplifications, where you factorize your question. Now looking at the way the terms have been put, okay, we have more than 3 terms, we have more than 2 terms, so this definitely is a grouping factorization. So first of all, you handle the brackets. So we need to eliminate the brackets first of all, okay. So we're going to multiply a 3 in this bracket, okay, and then we're going to multiply -2 with every single term in the other bracket. Okay, so let us begin. So see, if we say 3 times 2x, we get 6x. 3 times -4, we get -12, okay. Then 2 times x, we get -2x. -2 times -1, we get a +2. From here, now after removing the brackets, we are going to use now the grouping where we put the like terms together. So the 6x, it has a like term which is a -2x, okay. So we bring the 2x, the -2x, we rearrange it, so it will be with the 6x, and then the -12, the like term is +2. Okay, so from there we group them like that. In the end, we will have, okay, something like this. So 6 minus 2x, what do we have? Okay, good. We have a 4x and then 12, -12 plus 2. Different signs there. We need to subtract and maintain the sign for the bigger number. Okay, so the final answer is 4x minus 10. Okay, question 2. Evaluate -2 to the power 0 times -2 in brackets to the power -3. In this case, okay, so we're going to use indices. Okay, so when we look at the first part there, any number to the power 0, okay, any number to the power 0 gives us what? It's always a 1 apart from the 0. So the -2 in brackets to the power 0, that's a 1. Okay, and then times -2 in brackets to the power -3. Now, if you have a power as a negative, the way it is here, okay, the first step that you are going to do is first of all to take the inverse for your base. So our base here is a -2. So we're going to introduce a 1. So we're going to take the inverse of this base, meaning the 1 goes up and the 2 comes down. So this entire fraction now becomes a -1/2, then the power becomes positive. Now we can expand this, okay? So we need to expand it 3 times. So multiplying -1/2 times -1/2 times again another -1/2, okay? So 3 times. So we're going to get 1 times 1 times 1, so -1 times -1 times -1, we have a -1, okay? Then 2 times 2 times 2, we're going to get what? 8. So the final answer here, when we say -1/2 in brackets to the power 3 is -1/8. So times a -1/8, and then 1 times -1, we have a -1/8 as our final answer. Okay, so just make sure you use indices. Wherever you have a negative as your power, take the inverse of your base to have a positive value, then you expand it now. Okay. Question 3. Factorize completely 27y to the power 2 minus 3x to the power 2. When you look at this question, it is also a form of factorization. But now, here we have 2 terms. The first question, we had more than 3 terms. So we used grouping factorization there. Here, we are going to use difference of 2 squares. So The way it works, first of all, you need to take what is common outside, and then the quadratic factor, the difference of two square factorization will work with the terms that will remain inside the brackets. So in this case, first of all, let us find what is common. Okay, so when you look at our letters, the letters are not common, we'll go for the numbers. So the way we find what is common in the numbers, you find a number that can go into these numbers, okay? The highest common multiple, okay, that can go into these two numbers, okay, without leaving a remainder. In this case, it will be a 3, okay? So the 3 will go into 27. How many times? It goes there, okay? That is 9 times, okay? So now, we'll take the 3 outside. It means the 3 is common, okay? Then we open the bracket. So inside the brackets, 3 dividing into 27, we have 9. Okay, so here we have 9y squared. Minus 3 into 3, that's 1. So we have x squared here. Since we are factorizing completely, what remains inside the brackets here, it has to be factorized now using the difference of two square method. So here, inside the brackets, we are going to break down the 9 in such a way that it should have a power of 2. Okay, so what number can we multiply 2 times to get a 9? Good. So that number is a 3, meaning inside the brackets here we're going to have 3 squared, okay, and y squared, then minus x squared. So now if we have something like this, it is possible now for us to use the difference of two square factorization by now expanding it in 2. Okay, so the first bracket will have a 3y minus x, and the second bracket is going to have the same terms, but now with a different sign. Okay, so to have a positive now, then would have factorized completely. Okay, so the final answer there will be, okay, 3y minus x and then 3y plus x. This is the final answer. Okay. Question 4. A straight line L is represented by the equation 2x minus y equals to 5. Find the gradient of the line L. Okay, so this is the equation. Now, our first step that we are going to take, okay, we are not finding the equation. The equation has already been given. So what they are asking us is to find the gradient. Okay, so for us to find gradient, when we go back to our standard formula, we say y equals to what? Mx plus c. Okay, so this m is the gradient. Now, looking at our equation, it has to be put into standard form first of all, so that we identify which one is our gradient. So let us put it in standard form, and then later on we'll pick the value for gradient, which is the coefficient of x. Okay, so meaning 2x has to cross the equal sign. Okay, so this side will remain with a negative y equals 2. So the 5 didn't cross. When the 2x crosses the equal sign, we're going to have negative 2x. Okay, then okay, from here let us rearrange a bit. So we want our y to be positive. We're going to divide with a negative 1 on both sides. Okay, negative 1. Okay, so this y will be a positive now, and then the 5 will be negative, the 2x will be positive after dividing with the negative 1 there. From here, now that's when I can introduce my general equation for an equation. Okay, y equals to mx plus c. So the gradient is the coefficient of x. Okay, so what is the coefficient of x there? It's a 2. Okay, so m is equal to 2. So the gradient there is a 2. Okay, we proceed to question 5. Shade the region P intersection R complement intersection Q on the Venn diagram in the answer space below. Very simple. First of all, we deal with an operation at a time. So if you look at the R R has got a complement. Complement means elements that are not members of this particular set. So in this case, we are removing all the elements that are in set R. Okay, all the elements that are in set R. We get elements that are outside this. It means we can get elements that are here or here, okay, or in the universal set. All these elements are outside set R. That is the R complement. Now, they are saying the intersection of P and Q. Okay, so intersection of P and Q, it means we'll restrict ourselves to where? The portion will be right. Let me show you the portion. So the portion will be right here. That is where the intersection of P and Q will be. Okay, so this will be the correct answer right here. Okay, so that is the P intersection R complement intersection Q. It is just the intersection of P and Q. You remove the set R. Okay, question 6. The magnitude of PQ, of vector PQ, is 20 units. Given that vector OP is equal to 5, 0, that is a column vector, and then OQ is equal to 17, then Y, another column vector, find the positive value of Y. So these are positional vectors. Okay, positional vectors, they start from the origin, or the position vectors. Okay, so one thing that can help us is first of all to draw the diagram showing the position, the origin where these vectors are starting from. Okay, so we're going to have something like this, and this is the origin right here. Okay, so we're going to have a P on the far end, on the top end there, then on the bottom we're going to have Q here. Okay, so from O to P, this, okay, they're starting from the origin, remember, so the arrows will point from O going to Q or O to P. And then we've been given PQ in unit form as 20 units. Okay, so looking at the values that we've been given, we're going to first of all find the vector column for PQ, okay, so that we use it to calculate the value that is unknown there. So vector PQ is what we don't know. We've been given the magnitude, okay, so PO, we are going in the same direction as, we are going against the direction, okay, so P to O, we are going against the direction of the arrow. So we introduce the negative, so 5 will have a negative, 0 is a neutral number, don't put a negative there, okay. And then OQ, we're going in the same direction as the arrow, so no need to introduce negatives, so add there. So negative 5 plus 17, we add corresponding values. We're going to have a positive 12, sorry, because we are subtracting different signs. And then 0 plus y, of course, it will just be a y. So the final answer will be 12 and then y. So we have the vector PQ. Then we'll use the formula for magnitude of a line. Okay, going back to coordinate geometry. Okay, so we use the formula for magnitude, where we'll have magnitude of vector PQ will be equal to y squared, the square root of y squared plus x squared. Okay, so with these two values here, okay, the 12y in this column vector, the magnitude PQ we've been given as 20 units, so put a 20, open bracket, y squared plus 12 squared. Okay, so first of all we expand the power for 12. Okay, so 12 squared is 144, of course. Okay, from here you introduce a power 2. Reason why we're introducing a power 2 is because we want to remove this square root right here. So whatever I do on my right, okay, we do the same on the left. So I've also introduced a power 2 on my left. Okay, so 20 squared is what? Good, 400. And then the square root has gone. So we're going to have a positive 144 to cross the equal sign. That's to go to where the 400 is. So in short, we're going to have 400 minus 144, okay? And then on the other side, we'll remain with y squared, okay? From here, what is 400 minus 144? Good, we have 256. Then we introduce the square root now, okay, to remove that square. So square root on the y squared, square root on the 256. And the final answer becomes 16, okay? We proceed to question 7. Given that A is equal to, we have a 2 by 2 matrix, which is 4, 5, 1, 1. And B is equal to, again, another 2 by 2, which is x minus 1. And then 1, 2, and a 0. The first question is saying find the A transpose. So we need to transpose matrix A, that is making rows into columns. So row number 1, which is where we have a 4 and a 5, it is going to be changed into a column. Same applies with the second row. Or you can change the column into rows. Either way. Okay. So the answer will be 4, 1, 5, 1. Okay, that is the transpose of A. Then they're saying question B, find x if AB is equal to 10, 4, 2, 1. Find the value of what? X if AB is equal to this. So in other words, they're asking us to multiply matrix A and B and then equating it to this matrix that has been given here, the 10, 4, 2, and the 1, for us to solve the value for x. Okay, so rewriting it down, it will be like this. This is the matrix A, this is the matrix B, and this was the given matrix on the equal sign. Okay, so from here, we're not going to multiply everything. We'll just check where our variable is. So our variable will actually be used once I multiply my first row, since we are multiplying row by column, with the first column. So this row and this column. Okay, then we equate it to the first element in this matrix here. Okay, they will correspond to the first element there. So 4 times x minus 1, so 4 times this, you put them in brackets. So 4 times open bracket x minus 1 plus 5 times 2 equals to the first element in this other matrix, which is a 10. Then we solve this equation. So 4 times x, 4x, 4 times negative 1, negative 4, and then 5 times 2 is 10 equals to 10. So here we have like terms. Negative 4 plus 10 will give us a 6, of course. Okay, so there we have 4x plus 6 equals to 10, and then we make the 6 to cross the equal sign. It will be 4x equals to 10 minus 6. What is 10 minus 6? Good, we have 4, then dividing there, we're going to have x as equal to 1. Okay, so the final answer is x equals to 1.